Reminder again, join us on Slack to ask questions and keep the discussion going. So use the Slack channel, build a DS project, and stay updated. You can find event resources, our GitHub resources. You can stay updated on when our YouTube video for this session series will get uploaded to our channel. So please join this Slack channel to ask any questions that you have regarding the series. So I'm very excited to introduce our speaker for today, Kirthikka Devi Venkataram. She's a product manager and a design thinker, an industrial professional, over a decade of experience in creating customer-centric, safety-critical products, delivering value to customers and generating organizational revenue. After her Master of Engineering, she worked in cutting-edge technology products for industry sectors like communication, automotive, AI startup, and deep tech research laboratory and product innovation and solutions. She strives to uplift women in technology careers herself, encountering multiple career breaks. Kirthikka is a mentor at Products by Women and a volunteer at WWCode Data Science community. She participates in forums representing the technology space. She loves gardening, cooking, and traveling. Thank you so much, Kirthikka, for conducting this session today. And I hope you all enjoy. She's a wonderful volunteer and a very active participant in our community. And she has developed a lot of content for this series and other series as well. And I hope you'll learn a lot from Kirthikka today. Over to you.
Thanks a lot, Mansi, for providing me a wonderful introduction to the team. I'm glad to be here to host the session today. Meanwhile, can you just confirm if the screen is visible to you all?
Yes, we can see your screen.
So, welcome. I welcome you all for the second session of building a data science project from scratch. This is the second session, which concentrates on the exploratory data analysis and the data visualization that intends to tell a story, a compelling story to Jupiter. So, this particular session is to target the organization need to consider the opportunities aligning with the engineering team, product design, and the product marketing team for its strategic decision on new product development or product feature enhancement or to create the process solution using data. Let me throw a question to you. So what's the difference in the data that we use to solve a business problem using data science and a business problem that is solved using traditional non-AI solution? So I'm just quickly trying to collect your thoughts on how data is, or what is the difference between the data that is used to solve a business problem using data science specifically, or how do you solve a business problem using other traditional methods like non-AI solution? Do you see any difference in the data that is being used? Okay. So let me chime in to give you the answer. We do have the set of data, or the data set is going to be the same. How does it differ? Okay. I can see an answer like organized data and unorganized data. Thanks for giving this answer. But if I have to specify, the organized and unorganized data pertains to cleaning up of the data. What I was trying to get from you all is, what is the difference in the data set? Do we have any difference in the data set actually? How do we decide that we need to solve the business problem using a data science approach or an AI in the language? Where does this part of AI and ML comes into picture, where we have solved a lot of business problems without getting into it? Generally, what happens is the concise concentration for the organization and the development team is to spend much time on the data analytics part to derive meaningful output. So what they try to do is their primary focus in all of this process is to be the voice of the customer. First point. The second point would be they would try to create value to the customer. And the third point is they try to meet the organization goal and generating revenue, which is the foremost and priority in all cases. So whenever we try to see organization goal meeting to it and generating revenue is the foremost goal of any organization or serving the customer in turn. So this means like, where does this data analysis part or data analytics and the data visualization part gets its importance? When we say when you have to solve a customer problem, we have two approaches here. We don't solve the customer problem, conducting the customer journey, just driving down to them and then understanding their pain points or get their requirements, shadowing them, and there are many different techniques to understand customer requirements. The other approach is you have some data, maybe a primary data or secondary data which is there. How would you use that data and what would you do with that particular data? There comes the meaning of finding insights from the data. So what do you do in turn? You just try to use or leverage the power of AI and ML to find new business requirement, to create a new business use case, to create an own business case altogether with the data, and then build a data-centric approach of product development. There is also one more approach which I leave to the thoughts of the viewers. So now let me start, like when you see or when you try to visit the data, what are the types of or what are the steps that you generally follow? You just start with the business requirement. You just try to understand what is a business need and gather data accordingly. Then you perform some kind of cleaning mechanism, perform the exploratory data analysis, visualize the data that you have at hand, and then do a predictive modeling or a type of modeling which is aligned with the business requirement or the business problem that you're going to solve. Then the final step is like to fine tune it and to make it accessible, which makes it to be highly relevant for users to use the educational process. So if I go to a problem which is a non-ML based approach, does the same cycle is being followed? So this is a question thrown to all of you, like, do you have the same cycle of product management cycle which is being followed? Does it holds good for any non-AI/ML project? I did not get any answer for this. So which means I evaluate that the users are knowers, and let me also explain it to you. The process of handling the data or the data product management in a non-AI and ML based project is like they conduct a data gathering part or they try to understand the business requirement, they perform data analytics, and then they decide like, do we really need to have a data science approach or a statistical based means of deriving insights to create a data driven approach or decision on the problem. Which means like I get a message that there is a minor disturbance in the mic. Can I confirm like the viewers are able to see and hear me clearly?
There we can hear you and see you, but your voice could be a little more clearer. Otherwise, it's like legible.
Okay, great. Let me just quickly get my mic there to one. I try to find it out. Is this better now?
Yes, much better. Thank you.
Fine. So we were discussing about in today's session the opportunities that the organization would be aligning with the engineering, product design, and marketing team to get a strategic decision on the new product development or the product feature enhancement, or else altogether to create a process solution using data. So what I was trying to explain here is like the organization generally concentrate on their to generate revenue and to meet their goals. What they also try to figure out is to meet the customer needs, to create value to customer and be the voice of the customer. So where does this data visualization or exploratory data analysis comes into or fits into this model? We are seeing from the top-down approach where we generally gather the business requirements, we perform exploratory analysis or a basic data cleaning, visualize it, and see if we can get any insights from the data. Then the next process is we perform feature engineering and to try to find out the features that are relevant for our model. The step after this feature engineering is to model. It might be a predictive modeling or it might be a type of ML, any different type of ML model that we create pertaining to the business problem, and then we evaluate the model by fine-tuning it based on certain hyperparameters which needs to be fine-tuned on a regular basis. This also holds good when we add new data to the existing data set. This is true for any ML-based project. For any data science project, we consider to use the statistical know-how. We also understand the domain under to which we work. Like it might be a finance-based, it might be a healthcare, or it is going to be an automotive or telecommunication, or whichever industry that it is that we are trying to apply the data science project. We could be trying to automate it, or we would be trying to create a new model with the data that we have in hand, or we would be trying to create a new business case altogether with the data using the data-centric approach. So during this particular discussion, what is most prevalent with the current business model and majority of the industry sectors that uses the spoiler AI is, they use this data-driven approach using two types of triggering. One is like the proactively triggered approach and the second one is reactively triggered. What does it mean is like when you proactively trigger a product-based decision, you are creating something new out of the data that you have in it. A reactively triggered approach is you fine-tune or you try to optimize your process, or you also align with the business goal of meeting a new feature or enhancement of the product altogether. So these are the two approaches which is generally triggered. Now, getting into our focus of what we do in the exploratory data analysis is, we try to reason out with a proper aesthetic way of data being handled. What do you mean by a proper aesthetic way? We make the data beautiful. How do we do that? Do we add separate value to it? Yes, we do. How do we do that? We first cleanse the data. We organize it in a way that it provides a novel and informative approach, or a novel and informative way of dealing with it. And ultimately, it provides you an efficient way of delivering value from the data. How do we do that? We just focus our energy on the data intense insights, building a compelling business requirement to solve a business problem. And after this, what do? We visualize the data and then build a story accordingly to prove our data decision approach with the data that we have in it. So do you think it is all quite easy? Definitely not. What happened in 2008 is like the presidential election results from the New York Times was published in this particular manner, as you can see. The US map was segregated based on a visually appealing content that shows with the placement of the state and differentiating it with the color where the two parties have won. Based on this particular approach, there are many different data visualizations that are helpful in our day-to-day life. Say, for example, we do have numerous data visualizations like interactive dashboards that we have it in hand. We also try to visualize the stock share market data live. So all these are done with the help of data, which is the fuel to us. How do we use this fuel is our question. Currently, we are trying to solve a business problem or a problem statement that was discussed by one of my colleague, Lindsay, who stated the problem like the Spotify's problem song attribute statement, problem statement, which deals with labeling the data or classifying to have a build a classifier that labels the data as a song for a particular user with a set of data which is available from that particular user. As if a new song is given, we could classify that as the user will like the song or he doesn't like the song. How do we do that? Are we going to build a complete classifier in this? Absolutely not. In this particular session, this is a very basic session where we try to understand how are we going to use this fuel to trigger many other different use cases. That is the target of our session. So, seeing one great example of visualization, what is done in the visualization? We build a format for the data representation. Like data is of categorized into two major types. What is it that? One is the categorical data and the other is the numerical data. What do we do with the categorical and numerical data? Categorical data will have two other bases of nominal and ordinal. And numerical data has integer and interval and ratio kind. What do we do with these data? We make informative decision, like we intend to create some message out of it. We use a context to use it and with the help of few visual aids and tool, which is what that we are going to see in this particular session. Then you design your visualization to reveal the ambiguity or as creating an evidence for your decision. The dependency with the independent variables are also derived. How do we find that? Is through a feature mapping. Then what we do is we make it much more efficient by critically aligning it with the data points, with the available data points. And also we create a content like particular relation with the data that is available, with the data nodes. And how do we do that is we emphasize it, leveraging the aesthetics. What does leveraging the aesthetics means? We just place the data correctly in place, like where it has to be. We provide them color, size, and label that makes it more appealing. As we know, every data is like as seen as a raw data doesn't make any sense, but on an infographic or on a graph or table or on a chart, more than a table gives more or adds more value. The emphasis of this particular issue is like prioritizing your visual aid part. This could be done by using or making the data to be prioritized and send a message to legitimate choice of creating attention to your data, to the audience. So right now in this particular session, we are trying to understand what the data of Spotify song attributes are. A single attribute has 13 there are 13 attributes. There are 13 columns related to it on a single row, which gives you a dependent variable called target, where this particular variable concentrates on liking a song or the user doesn't like the song. That is done with the help of this, the notebook, which could be shared meanwhile. There is a collab, and this is also available in my GitHub. You can also download it over there. You have the first step of exploring the data. What we do is we collect the data of the Spotify song attribute, and then we try to do some kind of cleaning process, as well as to do some descriptive statistics over it. What are the types of data description that is available? Can I just meanwhile understand, like from the audience, what are the types of data description that is available? There are three types of statistics that we could do on data. One is descriptive, the second is predictive, and the third is prescriptive. So all these are quite normally used statistical means where pertaining to a business problem, you try to pitch in this required type of method and then try to derive insight from that. So here I have created, this notebook is created specifically for visualizing the Spotify song attributes. The 13 column data, the columns are like completely seen over here. And what we try to understand is what is the categorical data and what is a numerical data here. And we get a count of the data as well as we align it, creating description of it, a descriptive statistics out of it. As you all know, this is all quite normal or the basic statistic notion which is available to every STEM user as well as a reader, also to wide range of audience who are available here. I completely assume like you are aware of the basic statistics, and I just skip through all these steps. So what I do here is I'm just trying to find out if there are any null values and then sum it out if you find any null values in the data set. And the next step is I find out if there are any skew which is available, if it is aligned to, if you have a right skewed or left skewed content. The mean, median, and mode are quite important in analyzing any data. When you have an outlier, it is easy for a user to identify if you know that the median and mean are not equal. If they are quite equal, there are no outliers which is found in the data. So the skew will also give you an indication of if it is right skewed or left aligned skewed distribution which is available with the data. So there are means of distributing the data, or there are means of scattering the data. What is right for your data is pretty much or prevalent with the business problem that you try to solve. Here, all these 13 column attributes are quite unique, where you need to understand what is the domain that you're working with. If you have to understand this, you need to dig into the Spotify attributes, which will be shared in the which will be shared in the comments, or which will be shared in your sorry to interrupt. Which will be shared shortly. And after this, what I did is I was trying to understand one particular variable, energy. I'm just describing the variable energy, where you will also have to understand by your specific business need, which is the particular or key parameter, key attribute that you wanted to describe. There lies the question of finding it out if the data is quite good enough for you to move forward, or do you need any furthermore data cleaning process to be done on it? Because all these values or attribute is specific to domain, and you need the domain knowledge to move forward. Then the next step, what I try to do is to find unique artist. Artist is again one more column attribute, and I'm dissecting it to find unique artists who are prevalently used by the particular user. So as I have already mentioned, the problem statement is by a particular user, you're going to build a classifier if a new song is provided with the set of data set that is available from that particular user. Will the song be appealing to the user or not? Now, after this particular step, I'm just trying to collect the unique artists who have secured more number of times the user's mind. So that is being listed out. So the next step after describing the data is to do an in-depth exploratory data analysis. During the exploratory data analysis, you provide an initial data analysis. What does the initial data analysis does is you categorize the numerical and categorical variables, which could be discrete or continuous, and then you try to segregate them separately, provide them a distribution of plot. That is what is done over here. So this plot describes a quite distributed value around a range of axes where each of the attribute has its own importance, and you need to find out which attribute is going to help you out in your next process like feature engineering and to build a model. Now, collecting this information, I'm just trying to, this particular tab and the next particular tab is exactly from one of the reference which is available in the Kaggle datasets, which I will also recommend you to have a look into the complete EDA visualization done by one of the user for this particular dataset. This tab deals with distribution of continuous feature, and the next tab deals with the distribution of the discrete feature. Hope I understand, like the audience are familiar with the discrete and continuous variables or the discrete and continuous data which is available in this particular data set, since this being the continuation of the last session. And the next plot is to understand or to know the distribution of categorical variable which is scattered out. So scatter plot gives you the relationship between two variables which is distributed or which is scattered out. You can find the density of the values of one of the attribute danceability to the target, which specifies if the user does like the song or not. Similarly, I have thrown swarm plat for one another attribute with the target being the dependent variable. The next step, what I try to understand with the particular data set is, does this data set will be useful for any particular use case? Like, will a new song which is given to me, or will the set of songs that is available to me already in the data set falls into a category of danceability? Danceability is again one attribute which is required to understand if the particular data is useful for a dance party. The tempo, vibrant, and other attributes which are related to the song attribute is quite evident for a person to dance with the danceability attribute is what I'm trying to visualize. So I'm just categorizing the value into 3 buckets and I have displayed it as a bar chart. So now, the same thing is done to tempo. Tempo is also categorized and I'm trying to visualize it. Will the music is less vibrant, mid-vibrant or high vibrant, and trying to get the percentage of vibrancy that the user is aligned to or elevated to. After having the particular data in my hand, I can also create a different type of use case. Like all these are completely independent use cases which doesn't have any relevancy. So this is how you try to visualize any particular feature or visualize any particular data that will be useful for you to build a use case in future. The next step is I am visualizing a seaborne visualization is being done with the target, considering the tempo as my density of the target with danceability and energy as attributes. What is these attributes will do is like they show me if there is a difference in the target, which means if the user is really aligned to the music that he listens to, does it has any difference with the danceability attribute and the energy attribute? Generally, when the energy is high, the danceability attribute is also high, which means they are directly correlated. the same kind of different plots are thrown to you to show you like how different ways of data visualization could be done. Then after having a different uh, attribute to be visualized, I have also captured many different approaches like a three-way ANOVA based statistical data based approach to visualize the data. Three-way ANOVA statistical data is a methodological approach to find out three independent variables which are categorical and one dependent variable which is numerical, and what is the alignment or the correlation between them, and could you be able to derive any insight out of it. All these are pretty much important business use cases and which could be used to enhance your product feature in turn. Similarly, a display plot is also used to find out the different values of key that has its importance towards danceability. The same thing is done using many different types of plot. You can have a look into it. Meanwhile, I just wanted to concentrate on the pie chart which shows the percentage of mode, the percentage of balance with mode into consideration. So all these different types of charts or altogether throws you an understanding of what are the different attributes available. Since because we do not concentrate on a specific use case apart from labeling it, which is already done in this particular data set, we just try to dissect and we just try to understand the data in many different forms. We also, at last, in the data visualization part, get the percentage of the songs that is being liked by the particular user. You might be knowing like this is taken from the Spotify API and you have an access to it to collect the data directly from the developer account that you have with Spotify. There are different techniques, tools and techniques which are available to you for hearing about the data. There are Python-based tools, there are Python-based libraries. Here, in this particular session, I have concentrated on Python-based libraries where we have seen two to three different libraries earlier, and now we will be concentrating on Plotly. We also have automated tools, and we also have low-code ML tools, which could be used directly to interact with the data and create a dashboard altogether quite easily in minutes. I have also done it in the past, and maybe in this session, we are not going to concentrate on that. Instead, we will be concentrating only on the data analytics part using Python libraries. So here, what I've done is I think there is a kind of, till this point, it is fine. There is a mismatch over here. We have to start building our project. And meanwhile, while I built the rest of the project, I just wanted to concentrate on the different types of charts which is usable to us using Plotly. Many would be aware of the statistical importance of using mean, median, mode, and what or how it is generally used to find out the skewing. This plot, which is the violent plot, is quite important to us right now in this particular project to understand where the data lies. Okay, I think the screen is slightly scrolling up. Can you confirm if you're able to see my screen? Can anybody give me thumbs up and provide me the confirmation like you are able to see? Okay, great. Fine. Yeah. Right now we are concentrating on display method, which is quite easy using Plotly library. The violent chart. This particular chart is quite same as a box plot. What is the difference that you can see with this particular chart? Can anybody of you give me an understanding of what is quite different or what is quite same with the box plot approach? First, is there a familiarity with violent chart from the audience? That would help me out to dissect this particular section. Okay. So violent chart is quite same to represent the data. What is differing with it is the kernel density which is available. What does this kernel density gives you is for each particular instance, what are the different attribute values at that particular instant. Boxplot will not be able to provide this to you, as well as bar chart will not be able to provide this. This is an intuitive and attractive way of analyzing the data in depth to understand particular instances of the box plot using violent plot. So I'll just quickly navigate to our next set of plots. This plot gives the importance of showing you the top user or the top artist that is being heard by the user. So this is quite important for any kind of recommendation product, any kind of recommendation building software model that you're going to build with ML. This is highly significant in that particular aspect, as well as you will also be able to derive pretty much different use case, like with this particular artist, from which country does this artist belong to and how are they related in getting the top count for this particular user. So there are different types of predictive modeling, as well as different types of modeling approaches, which is available as an automated format with the feature engineering approach that we will be seeing in the forthcoming session. And to move forward, I will also give you an understanding of the different attributes which is being shown as violent plot for the top 3 artists that is heard by this particular user. So why do I need this? Why do I need to dissect only for these particular artists? If this is going to be for a single user, why should I have to do this? Can you find out any use case that is helpful for having this visualization? Okay. Meanwhile, I'll just give this as a thought to take it up as your assignment, which will be discussed in the bonus section. Fine. There are also different other charts. This is one of an important chart which I would like you to understand and try to figure out why we need this particular chart. And if you have any questions, please revert back to me. I'll be happy to answer to you all. So all these different kinds of charts show you an understanding of how the attributes, it might be one categorical variable or one or more categorical variable associated. It might be one categorical and one or more numerical variable associated. It might be numerical value to a numerical value association, which means you can see the association of we can do a bivariant analysis, and also you can do a univariant analysis. Obviously, you can do a multivariate analysis with the data that is there in hand. And how do you visualize it, and what is the importance of this particular density is all dependent on the use case that you're going to build. Every single chart has a specific use case, and it will be helpful for you when you try to understand the domain specific need of this particular project. It is same for any data science project that you try to build. So, understanding about the data, performing an exploratory data analysis, I am currently jumping in to understand if my data has any outliers. So after having a data visualization, why do I do an outlier analysis at the end? Why don't I do this outlier analysis in the beginning of data visualization and try to understand the data? Do we have any thoughts on it? Okay, comparing artists, like how was it related to do an outlier analysis after an exploratory data analysis? Do we need to do this kind of box plotting the data or finding out outliers in the data during the beginning of data analysis? Since because there are certain projects and here also we don't have any specific use case. We do not try to portray the data to be having outliers with just the data in hand, because we might have a use case where we do not want, maybe take this particular example. We have the target value, which means the user likes and doesn't like the song, and instrumentalness is considered. Target being a dependent value, I have made it as an independent value, and Y being an independent value, I have made it as a dependent value. So in this case, the complete transformation could be noticed. So complete transformation could be noticed when you plot the particular chart, when you plot this particular plot. So how do we how do we understand, like, if liking or classify or building a classifier is our only objective with the data available? This is one approach where you could be able to find out, yes, my target is already known. I know it. It is already labeled as 0 or 1. What do I do with this instrumentalness? What other feature or what other attribute could I add to it in my visualization to get an understanding of the data? And that is what is done over here. So that is a reason to give this particular thought process to you, so that you have many different ways of building the use case apart from building a classifier. Next, the last approach is to know the correlation between the attributes. In finding the correlation, the target and energy is less correlated, while the danceability and instrumentalness is highly correlated. But do they have a positive or negative correlation depends on the value that is there. You can clearly visualize energy and loudness has a positive correlation, and it has a strong correlation. Similarly, when you move forward, okay, I think it's taking a while. We'll just quickly move forward to the next section, or to have a pair plot approach where we visualize the complete set of attributes or the complete columns as a pair plot. Okay, I don't want to reload it right now so that the session gets interrupted. Meanwhile, you can have it as a background check in your system, doing this particular change of Y being the target and X being selecting one of the attribute as your selection, so that you proceed with a different use case. Similarly, to move forward, I have the set of, okay, let me show you if I have quickly. Okay. I think the collab is disconnected currently. I will not be able to show you the collab. If that is the case, that will be like highly helpful to you to run the code right now. And meanwhile, I request you all to run the code in background so that you get an understanding of what you can do with the data and how many use cases that you can build with this particular data set. Then, so what is the insight that you derive from this particular data set? As we have already discussed, there are two approaches, data-centric approach and customer-centric approach. In the data-centric approach, we concentrate only on the data, individual data, and then we build a product. We try to build a use case, we try to build a feature, we try to build a complete new product altogether, taking one or two product attributes into consideration. In the product-centric approach or the customer-centric approach, we analyze or we understand the business requirement. We understand the value of it, and then we try to gather data accordingly, move forward to derive insights with the data, or we also perform primary like a research method or a secondary research where the data is already available. You collide with the existing data and you create an insight or a data-derived approach or data-derived decision which is being built on the data. Okay, so having all this discussion into consideration, can you show me like which two attributes are highly correlated? Which two attributes have a high correlation in this heat map? I think you all might be aware of the heat map. If not, there is a share which will be posted on the chat to know what is a heat map. Okay, loudness and energy. If you could say loudness and energy, yes, they do have a positive correlation. And is that strongly correlated or does it have a weak correlation? So values above 1 and below 1 has a kind of way or a kind of approach to be dealt with. This heat map clearly shows you a correlation of particular set of artists. This is not the heat map which shows you a generalized approach. You can also see one more heat map which is over here. This heat map gives you the overall correlation of the data set. Meanwhile, the second correlation heat map gives you an approach of segregating the maximum the maximum number of times the user has heard to a particular artist, and they are segregated to form the heat map. You will be able to find the difference in the values. Obviously, there is going to be a difference, and obviously there is going to be a change, complete change in the correlation. So this is all about performing a visualization using data, and there are quite a number of tools which is available open in the market. You also have AutoML tools that could be used for building your model, not only for visualizing and also for building a model, identifying your features and perform feature engineering on it. There are also options which are open to you to do it from scratch using Jupyter Lab, and there are also options which are available to you to visualize the data in the data dashboard using Jupyter and by many other dashboards. Even Plotly has an option of providing a minute-built data dashboard. So it is all up to us to understand the data and to derive insights out of it. So to take back with this session, I want you all to do a small assignment on finding out insights with this particular data set. And you can also build your own visualization, you can also use this visualization as a reference and just note down your insight from the visualization which is available. You can also correlate the insight with any new business requirement. You can also build a use case with that. And it's all completely open to you. And I give you the liberty of coming up with many different use cases as you wish. So the last slide, this particular slide, gives you an importance of the feature engineering and the ML model, which will be discussed in our next session. And this is to have a glimpse of how the visualization of it would be like. Like when you use different feature engineering and build models based on it, what are the attributes that are highlighted and how far it is correlated, how far it is highly correlated with the different approaches that you will use. You will also have a separate session of understanding or doing a fine tuning on the parameters, where there will be a different visualization that you will notice over here. So this is all about today's session. And if there are any questions, I'll be happy to answer to you. So meanwhile, Gangana, do we have any questions?
No, Kirthikka, we don't have any questions as of now.
Okay, great. So I think I'm pretty much done with the session. And if you have any clarification or if you want kind of support, just reach me out. I'll be happy to help you out.
We do have a question from our audience. They want to know if we need to remove outliers before building the model.
Obviously, we need to remove the outliers based on the business problem that you're trying to solve. You concentrate on that particular data and try to remove the outliers from the data for which you are trying to move forward. For example, if we consider an outlier, maybe I will take let me take this particular plot. This box plot concentrates on tempo and the target as its attributes, target being the independent variable and tempo being the independent variable. So what happens over here is you obviously find kind of outliers which is seen for the value of target to be 1, which means the user who likes the particular song doesn't want a tempo level to be of certain level, which means you can recommend or you can provide a recommendation of songs that has a set of tempo values. When I say a range of tempo values, it's not a set of tempo values, a range of tempo values, I can also show you here. Yeah. In this, where we have segmented tempo. I have segmented it into 3 buckets, saying like the music which has less vibrant to dance and the music which is more vibrant to dance pertaining to the value of tempo, and that is segmented over here. Oh, I'm sorry. I think there is a small mistake over here. It has to be tempo and not danceability. Oh yeah, it has to be tempo. So I'll just quickly correct this and then provide you an updated version of the notebook. Meanwhile, you can also concentrate on segregating it. Yeah. So there was a quick change that I was doing yesterday night, and I think I missed out modifying this particular tab. Okay. Thanks for getting this to my notice. Okay. Did I answer the question? Did I answer your question? Thank you. Okay, I'll just have to quickly check on the values and then I'll have to provide you the results. Okay. I'm pretty much done with the session. Over to you, Mansi.
Thank you so much, Kirthikka, for a great session. The notebook is very, very informative. And to everyone asking for the session notebook, we'll be sharing every resource in the Slack channel, the Build a DS project channel. So you can, I know it's hard for everyone to copy it from the chat. So you can join the Slack channel, which we've shared with you all in the chat. So everything will be there on the Slack channel after the event. And now is the time to ask Kirthikka any questions that you have regarding the content of today's session. So if there was a problem, if there was a doubt in the code, or would you like her to repeat anything or explain anything, or if you have an extra question, something's that on your mind, you can clarify with her right now. Please drop your questions in the Q&A box.
To give an overall understanding, this particular session doesn't concentrate on the coding part. Instead, it concentrates on deriving this or to build your product, create a product to have a product decision, create new feature or enhance the product through the feature and things like that. So that will be helpful for you when you understand the data and when you know the domain of the data that comes from. And to also help you with, there are many dashboards, low code ML based, low code ML based, what is it? Web based applications as well as apps which are available for you to use it and build dashboards in just 5 to 10 minutes. And I think if you are not aware of it, I can share you the details later. Meanwhile, this notebook will be available in Women Who Code Data Science Git page as well as in my GitHub account.
We still have we're a little over time, but we can wait for any questions for another 5 minutes or so. But just let us know in the Q&A box if you have questions. Other than that, we are very thankful for everyone for joining us today. Hope you enjoyed today's session. We have 3 more sessions every Friday at 10 p.m. ET. And shout out to all our speakers, Kirthikka, hosts and moderators, Elaine and Gagna, for a great session today. And thank you to all the volunteers who prepared the slide decks and notebooks for this session and this series. If you would like to get involved in volunteer work with us, find more opportunities and information on our channel, Volunteer Opportunities, on our Slack. And if there are no more questions, we can close the webinar. I think we have a question. What low code reference are you referring to? Tableau, Power BI?
No, it's not Tableau or Power BI. It is a Jupyter based dashboard. There are many dashboards which are available. Tableau is quite easy for you when you don't have to do any kind of, apart from prediction, when you don't have to do any kind of modeling. But this particular session or this particular series deals with building a data science project, and we need to do some feature engineering and model building. Tableau will not be helpful for us in this particular case. Nevertheless, Power BI to some extent, but I don't think we could rely much on it. Instead, since we have exploratory data analysis to be performed on Jupyter, we have many interfacing dashboards like Hugging Face, like Volcano. Let me also share you the link of it so that it will be useful, so that it will be useful for you in future if you have to build a dashboard. So one useful dashboard that I found was with Plotly. That is quite easy for you to build a dashboard in minutes. Maybe I can share you the link right away. I'm just sharing the link to you all. This is absolutely an easy way of building a dashboard in minutes. There are also many other different tools which are available in the market, and I've tried few of them, but this seems to be appealing to me because it's quite easy to use.
Thank you for sharing this with us, Kirthikka.
Yeah.
If there are no other questions, I think we're good to close. Thank you everyone for joining again, and thank you for our wonderful volunteers for helping us with the session.
And thank you all for attending the session. Thank you.
Thank you. Bye, everyone. Hope to see you next week as well.